Hello everyone, I'm Dr. Sri Banerjee, core faculty for the College of Health Sciences and Public Policy at Walden University with a joint faculty appointment at Ross University School of Medicine. And in this video, I'm trying to show how the measure of association concept can be applied in not only everyday life, but also very important if you're taking the USMLE or any other board exam, crucial to understand. And these are basic epidemiological concepts. We don't get into a lot of detail you might find in a standard epidemiology text. What are we going to go over today? Well, in this video or audio, however you're listening, review the importance of the levels of measurement, apply appropriate measures of central tendency for each type of variable, apply appropriate measures of variability, and determine the difference between incidence and prevalence. And trust me, there's a lot of confusion there. Also, measures of central tendency. Students have a tendency to get that mixed up as well. So pay close attention. If at any point you're feeling like you don't understand, pause the recording, go back, and make sure that you're getting the concepts right. So this is the famous bathtub model. Many of you might have seen this, but just basically what it is that there is, and I'm trying to get a highlighter here. What it is that there is incidence over here, and those are the droplets that are going into the prevalence. This is a filled bathtub. Now, if you have recovery, then this prevalence actually goes down because some are evaporating. And then, unfortunately, if you have higher rates of death, that decreases the prevalence as well. So recovery and death are decreasing prevalence. Now, if this decreases death, if there's some sort of treatment that's going on, then this will become less of a leak, and that will increase the prevalence. So this is how this bathtub works. So again, if something prevents death, that increases prevalence. Prevalence and incidence are frequently confused. Prevalence refers to the proportion of persons who have a condition at or during a particular time, and that's where this is at or during. Got highlighted, and then this is incidence, refers to proportion or rate of persons who develop. So these are new cases, and then these are at or prevalence is the whole thing. So number of new cases, again, turning on the tap is number of new cases. Speed of recovery, which is influenced by disease severity and treatment options. So that's same as evaporation. And I told you, remember, the evaporation will actually decrease the prevalence in the bathtub. If you release the plug, the number of people that lose their lives to the disease. So if you release the plug, then the prevalence will decrease. So that's if number of people that lose their lives has increased. So if more people are losing their lives, it's because, well, prevalence will decrease. So when you have number of people that lose their lives to the disease, then because of the bathtub water not being as much, prevalence decreases. So now let's talk about the levels of measurement. So here we go. Usually we think about nominal as categorical. So an example of that is, for instance, sex. So it's male versus female. So that's the example. Ordinal, you have typically like 1 through 5 scale, and that is considered the Likert scale. And for those of you that don't know, it's looking at severity levels, but so you can find the levels of measurement and central tendency if you have a Likert scale questionnaire, which is very common. And then interval versus ratio. Well, basically ratio has 0 in it, and interval doesn't. And these are like age. That's considered, and well, depending on who you ask, age technically can be 0, but most likely it's a certain amount between, even if it's a decimal, and like 6 months, or just newborn versus old age. And so it's a whole range of numbers. Ratio includes 0, so one of the most common example of that is temperature. That 0 actually has a lot of meaning. So these are not only descriptions, but examples of what they are. It's also important to think of these. I told you this was categorical. Ordinal interval ratio is more continuous. So again, these are the most important portions of that. So I think a lot of this will become clear in the next slide. So here you see point prevalence versus period prevalence. And so prevalence is now talking about the number of cases of a disease in a specific population at a particular time point. And so that's prevalence. Over a specified period of time, that could be true as well. So when we talk about prevalence, we can either refer to point prevalence or period prevalence. Point prevalence is the proportion of people with a particular disease at a particular time point, and can be calculated. I'm going to show you the calculation in a subsequent slide. Also, number of cases at one time. This is covered by this, but you can see you'll see the difference between point and prevalence, period prevalence, in subsequent slides. So here's a Boxen plot, typical plot. Not much going on here, but important portions to notice is that this. I'm going to try to. So this is considered the 50th. This is the 50th. So 50, and then this is 75th, and it's very difficult to. So that's the 75th. So I'm kind of, I'm not going to show you here, but this is, not sure. So this is the 75th, this is the 50th, and this is the 25th. Now sometimes if they're saying at least 75th percentile, then you're going to have to add whatever's here and plus here, and then whatever's left over. So if you're looking for 60, if you're looking for the 75th percentile, or at least 75 percentile, then you're going to have to add all this. This was one of the tricky parts that many students have difficulties with. So thinking about the normal distribution curve, this is the most important curve in not only statistics but also epidemiology. So I would try to memorize this curve and try to think about what these represent. So this is, if you have a mean, then 34.1% covers before and after. And then you can use to create the 95th or the 60 8% off, 68.2. And then if you add this along with this, now we're getting 2 standard deviations away from the mean. So that means that this is now 95th percentile. So 2 standard deviation is 95th percentile. And you can kind of get the drift here. And so then if you're trying to go all the way to 3 standard deviations on both sides, then that would be considered 99th percentile. And you can kind of see it's about 2.3%. So you just keep adding. So this is the normal distribution curve. Again, one of the most important curves that you'll see in statistics, and you're bound to have questions coming from this. So just looking at this central tendency, it's important to note that where the mean, median, and mode are the most important. So what I would argue is that mean and median are most important in the continuous variables. And what are the continuous variables? If you answered interval or ratio, you're correct. Sometimes people say ordinal, so that's kind of iffy there, but I would say that's also continuous. So whenever you have a continuous variable, then you can actually go ahead and establish the mean. But I want to show you something as well that so here's more or less, here is the standard normal distribution. So what is going on for the mean and what is going on for the median? So the mean is equal to median. However, when there's skewness, if it's positive skewness, like that, then the mean, there's the mean, is greater than the median. That's called positive skewness. So I'm going to put positive. And then we're thinking about negative skewness. So then it's kind of the mirror. So here's negative. Here's negative. So for negative, what's the skewness? For negative skewness, where does is the mean less than the median or greater? So if you said mean is less than the median, you were correct. So there's the median. So this is negative skewness. So now in this, we're actually not going into perspective, just so that you know. Concurrent and retrospective are similar in type. It's just concurrent typically starts with the exposed, and with retrospective, you're supposed to be starting with the non-exposed. Now I don't think this is very important to distinguish between retrospective and concurrent. It's more important to be able to distinguish between retrospective versus prospective. Retrospective, again, you start with some sort of exposed and then see if the individuals had the disease or didn't have the disease. And you do the same thing with retrospective, but you're actually starting with the not exposed and then going into disease versus no disease. Again, these are going back in time, and there's nothing to control or change because you're just studying what diseases might have gone into the exposure or not exposure, and so by that you can discern and understand the relationship. So another important topic that students have problems understanding is cross-sectional, specifically cross-sectional and case control studies. In case control studies, you take a look at the cases. You take a look at the cases here. And so you take the positive and the negative. Say you have the outcome you're trying to do is mortality, and then you go back and compare the cases and controls and see what risk factors they had. So you're not really actively doing this. This is all from selected cases and age-matched or sex-matched control, so that you have a control that is more common to the whole population rather than something else. So then another area that I wanted to talk about was types of studies and quality of evidence. So typically, if you have a background information, that's different, that's unfiltered information. But then filtered information, take a look at this, how this is different. It's really important to keep track of. So you have this area, all in filtered information, and then unfiltered information is your observational studies. However, randomized controlled trials can also be experimental. So the final slide just looks at the types of observational studies that are out there. For instance, cross-sectional study and case control studies. So cross-sectional studies, individuals examined at a single point in time. Case control, individuals with a particular outcome, individuals without a particular outcome. Then you're looking at the factors present. Now, all of these are considered still cross-sectional. The only one that is longitudinal is either the cohort study or the randomized control trial. So you can make more conclusions about the causality than the case control or cross-sectional ones. So that's about it. Thanks for listening. So now in this slide, I will be going over the measures of association. And if nothing else you get out of this lecture or audio, just please note, this is one of the most important parts, which you'll see either in the USMLE or any boards. So cross-sectional is always odds ratio, no matter what you're collecting odds ratio. With case control, odds ratio as well. However, when you're thinking about cohort, perspective or retrospective, you're looking at relative risk. So just to look at measures of association now, when you're thinking about the odds of exposure, then it's A times D divided by B times C. So this is what? It's odds ratio. Now, when you're thinking about relative risk, then that is A divided by A plus B and then C over C plus D. And so which studies are relative risk? Prospective and retrospective. And again, odds ratios, case control, and cross-sectional. So the final slide just looks at the types of observational studies that are out there. For instance, cross-sectional study and case control study. So cross-sectional studies, individuals examined at a single point in time. Case control, individuals with a particular outcome, individuals without a particular outcome. Then you're looking at the factors present. Now, all of these are considered still cross-sectional. The only one that is longitudinal is either the cohort study or the randomized control trial. So you can make more conclusions about the causality than the case control or cross-sectional ones. So that's about it. Thanks for listening. Now if we look at this contingency table, or table that shows some of these, again, in here as well, new drug versus standard drug, cured versus not cured. Again, the odds ratio for this would be AD divided by BC. And so this has kind of similar. And then if you want to do relative risk, which is probably a more suitable sort of measure here, it's A over A plus B divided by C over C plus D. So the incidence is the number of new cases of a disease divided by average population and disease. So new cases is the key here. So if you can see the whatever provided here, is that number of new cases again. So this is important to note. Now prevalence, point versus period. Point prevalence is the proportion of people with a particular disease at particular time period. Now when you're thinking about period prevalence, that's actually in a given time period. And so if it's like 2009 to 2020, then that's given time period, the prevalence. So it's not just in one time, it's multiple, like multiple years. So I wanted to end with this. This is one article which establishes many types of different concepts. For instance, looking at limitations, looking at confounding, some of the basic epidemiological concepts. I also wanted to leave you with what we've covered within the lecture here. So we went into the difference between incidence and prevalence. We looked at measures of central tendency, levels of measurement. Levels of measurement are nominal ordinal interval ratio, and then we went over some of the measures of association and understanding the difference between cross-sectional versus case control versus prospective cohort versus retrospective cohort. If you get these, then and you're going to be doing well in any of the boards out there. Thank you for listening.